Previously, we looked at the price elasticity of demand, the relationship between price and the quantity that a consumer will be willing and able to buy. Now I'd like to change our focus and look at the relationship between two products, and that's called the cross elasticity of demand, or the cross price elasticity of demand. What we're looking at here is how the price change in one product will impact the quantity demanded of another product. And this is important for us to help understand relationships as well as to anticipate changes in the marketplace. Now, we also, in talking about demand, we looked at this concept of a determinant of demand. And remember, a determinant shifted the entire demand curve, either left or right. And the cross elasticity is basically capturing the magnitude of that shift that results from the price change in another product. So what I'd like to do is take a look at an example of the cross elasticity. So now imagine a family is going to the beach for the day, and they want some protection from the sun, and they have, say, a whole bunch of options. Let's pick two. Imagine the first thing I could do is use an umbrella, and so I could use that, put that up on the beach and be protected, or I could use sunscreen. And so let's look at the relationship between those two products. And so here what we have is some sample demand. Right? So point A for an umbrella at a price of $50, consumers would be willing and able to buy 110 units. At a price of $60, consumers would be willing and able to buy 90 units. And then for sunscreen, we see that at a price of $5, consumers want 250 units, and at a price of $6, consumers would want 225 units. And if we think about what this then is representing, we really have two markets here. So we have a market for umbrellas with a price and a quantity, and we have basically 2 points on that demand curve. And then we also have a second demand curve, and this happens to be for sunscreen. And again, there's 2 points on that demand curve. So this point here with the higher price and the lower quantity, this would be point B, this would be point A, this would be point B, and this would be point A. And so remember, the price elasticity of demand really looked at how big this change in quantity would be from the result of that price. So as we increase price by $10 and we drop the quantity, we'd actually see sort of what's happening to demand for umbrellas and would see what's happening to demand for sunscreen. Now, if we went through the process and calculated the price elasticity of demand, we'd see that the elasticity of demand here is 1.1, and the elasticity of demand here would be 0.579. Now, it's a good test to see if you could go back later and calculate the price elasticity of demand here for these two products. What we want to do now, though, is really focus on what happens as we change the price of an umbrella, but we leave the price of sunscreen alone. And so imagine that here the two prices that we're considering at $5 and $6, imagine that this price of $5 stayed the same while the price increased over here from $50 to $60. And so this price increase over here, what's that going to do on the sunscreen side? Well, what's the relationship between these two products? What we see is an umbrella could be used as a substitute for sunscreen. So as the price rises over here, we would expect then, even at $5, that there's going to be some people who actually want to buy sunscreen now instead of the umbrella, and that would represent a shift in the entire demand curve. And the cross elasticity then is a measure of how big this shift is, because it's going to measure the change in quantity that results from that. So now imagine over here where we have sunscreen, right? Instead of this being 5 and 6, we really have 2 points at 5. And so imagine a second quantity here where the quantity rises to 260. So what we're saying is this was 250, and now it's 260. So that increase from 250 to 260 units that results from the price increase of umbrellas, right, that's the cross-elasticity of demand. So let's take a look at how we would calculate that. So the cross-elasticity is really still looking at the percentage change in quantity, but for sunscreen. And it looks at the percentage change in price for umbrellas. So it's really looking at both products, right? This price change over here and the quantity change down here. So this formula then, what that's going to really look like is the same thing, the percentage change in quantity. This is 260 minus 250 all over the midpoint. So remember, we pretend like we're kind of starting in the middle of these two pieces, and then all divided by the price change, but the price change is coming from the umbrella market. And so in this case, it's going from 50 to 60, so it's 60 minus 50 all over 60 plus 50 divided by 2. Now remember, there's a lot of order of operations problems here. So it sometimes helps as you're looking at doing this calculation is really thinking about doing it in steps, right? So calculate the midpoint first, calculate the midpoint first, calculate the difference, and then find the percentage changes sort of in those. If you go through that process, what you'll find is that this is 0.216. And this 216 then is telling us about the relationship between these two. And we can always think about this as, well, what if it's over 1? And this then, the 1 down here, right, that's our percentage change in price. So a 1% increase in price would lead to, what, a 0.2% increase in the quantity demanded of sunscreen. And so the interpretation of this then is really helping us to understand how these products are related. And notice that if we were to describe this relationship, we would say what? That this thing is a substitute, right? A sunscreen is a substitute for an umbrella is a substitute for sunscreen. Now, of course, you should always use sunscreen if you're out in the sun, but some people would indeed make that switch between these two. So you'll notice that this thing here is positive. The result of this equation is saying that they move in the same direction. Right, so as the price rises here, the quantity rises here. If the price dropped here, the quantity would drop here. And that's exactly what a substitute should be doing. Right? If this price sort of decreased, then we'd expect demand to decrease over here as a result of what? That substitution effect, right? Sort of some people are going to substitute an umbrella for the sunscreen. Now, one question that we could ask is, well, what would this look like if instead of having the substitute here, that this was a complement? Well, what would a complementary product be? Well, let's say instead of sunscreen over here, that we talk about this as, say, tent stakes, right? We don't want our umbrella blowing off in the wind, and so we need something to keep it detached or attached to the ground. So let's change this and talk about what this looks like with a complement. All right, so let's take a look at what this would look like if instead of a substitute, we used a complement. So that demand for tent stakes. Now, of course, demand for that is going to be made up of people who use them for other products, right? People who are camping or actually using them to hold down a tent. But a portion of that will indeed come from people who want to secure something like an umbrella. So let's look at demand for tent stakes and then the relationship between these two products. So here I have the demand curve for tent stakes, and at a price of $5, there's 1,000 units sold. Now imagine that the price over here still rises from $50 to $60. What's going to change over here? Well, as the quantity drops of umbrellas, people need fewer tent stakes. So we would expect then this to be now some smaller number. So let's imagine that that's 920. So a difference of 80 units here. That would represent a demand curve that's shifted to the left, right, as demand decreases. So then looking at that in our cross elasticity, right, this percentage change in quantity is now going to go from 1,000 to 920. So this is 920 minus 1,000, all divided by the midpoint. And then we do the same thing. We look at the percentage change in the price here, going from 50 to 60. So this is 60 minus 50, all over the midpoint. And we see that as the two calculations here are done, you'll notice something, that the numerator up here, 920 minus 1,000, that's going to be negative. Right? The denominator here, 60 minus 50, that's going to be positive. And so the result of this is actually minus 4.58. And as we think about interpreting what this result is, right, this basically says that a 1% price increase in umbrellas will lead to a 0.4% decrease in the quantity demanded of tent stakes. So the really important part of the cross elasticity here is thinking about the sign of the answer. And you'll notice we didn't use absolute value here like we did with the price elasticity of demand, mainly because this is what's telling us an important component of the relationship between the two products. In this case, our result is negative, and we see that the relationship between these two is that the products are complements. And when it was positive, the relationship between the two was that the products were substitutes.